Dear viewers, this video which is covered the dynamic voltage restorer DVR with that is the PV integrator. This instrument which may be going to change as a photovoltaic array. So right. So this is nothing but the PV photovoltaic array. This is we are going to change in terms of PV photovoltaic array, right? Suppose I am also already published one video. So that video which covered the single phase dynamic voltage restorer. So which can be used for the power quality improvement, which is we are going to satisfy the voltage sag control. So this video we are going to transfer the power. We are going to transfer the power from PV to load. We are going to transfer the power from the PV to load. Okay. So that is the power from this supply. This is the P. This is the power. That is the power from the grid. Power from grid. So this is the P of L. Power of the L. So this is we are going to improve, that is inject the power, that is the inject the power from the PV, So we are going to inject the power from the PV and satisfy the sensitive load. So this arrangement we are going to see, right? So what is the basic concept? All the FATS device, flexible AC transmission device, which means that is the line current, that it may going to inject the voltage. So this is the voltage injection. It can be injects the voltage near to, that is the 90 degree in phase quadrature with the line current. This is the concept. So based on this concept, we are going to inject the voltage with respect to quadrature of the line current. We are going to obtain the voltage sag compensation and real power injection. Suppose if we are going to do the real power injection, how we are going to obtain, that is the real power injection. So that is in the different case we are going to see. So what are the cases we are seeing for the compensation of the voltage? Suppose please see, that is the concept of real power injection here. So that is the line current which is we are going to added with the degree of 180 degree for the power reversal plus 90 degree. So we are going to get, that is the 270. So 360 minus, that is the 270. So which is the 90 degree. So this 90 degree of the supply which may be in phase quadrature with the line current. We are going to see that one by one. So how it is possible? So this is that the source, AC source, and it can be connected with the series with the line resistance, which may be act as a line. What type of line? That line contains, that is the only the R component, resistive based component. So we are going to feed that the load, one of the non-linear, that is it's a variable load. That is the variable load. This load which can be varied, so depends upon this the input. So this is that the variable load. Again, it may be connected with that the series transformer. What transformer? This is the connected through the series transformer. This is the primary. This is the filter capacitor. Here both sides we are going to connect it for the filter capacitor. So suppose if we don't want the dynamic voltage rheostat function, again we are going to connect or bypass this series transformer by using this breaker. And this single phase breaker, which is used to bypass the operation of this series connected device. Again, this series transformer, which is connected through the that is the inverter. This inverter input is a DC source is obtained from the DC to DC converter. So this is the DC to DC converter. This is a DC to DC converter. We are utilizing that simple converter. So what is this simple buck converter we are utilizing? So after that, this is the PV MPPT, perturb and observe, P&O method, perturb and observe method. So we are going to get the input from that, the measurement input from the PV panel. So we are going to get the terminal voltage of the PV panel and the terminal current, the corrected output terminal current. So this voltage and the current is fed into the this P&O based MPPT algorithm. This is a MPPT algorithm, right? So what is this? This is that is MPPT algorithm. Okay, so this is the MPPT algorithm we are implemented. Again, that is the RMS value. It is the ripple is occur. So that is the RMS value we are obtained that the what is that the different types of waveforms, that is voltage and current we are going to obtain. So next we are going to connect that the PV panel, that is the output of the PV panel is connected to the DC to DC converter. Again we are going to see the entire circuit operation. First I am also going to connect one nonlinear load. During this load which can be changed for the certain period at the time of 1.5 second. Please see. So we are going to change this variation at the load changing variation. Load changing variations is 1.5 second. Okay, at the time of 1, that is we are going to obtain that what is the value we are going to be changed here. So that is the next point. What we are going to do it in the this is the series transformer. This series transformer which is integrated through the, this is a 3-phase inverter. So this is a 3-phase inverter. This 3-phase inverter is fired by the this firing pulse generation circuit. So the required value of that the component is obtained from that the from externally, from the magnitude from that external go to and the input signal, we are obtained. Based on that value we are utilizing here. So that is whenever the load change is occur, the input irradiations will also going to change at 0.5 second. Okay, so up to 0.5 second, that is the low voltage, it may be occur between the two terminal of the PV. So after that, that is the 850 that is watts per meter square irradiation is changed. So again we are maintain the temperature of that PV at 25 degrees Celsius. Again it may be connected to that the DC to DC converter. Through this DC to DC converter we are going to obtain the what is the maximum angle. So what the angle difference we are seeing here, that is 90 degree and upon. So please see, this is the 90 degree deflection. So here I am also going to give some other that is the value. We are going to obtain minus 185. Oh, it's more than 180. That is the 180. So why I am going to put here as a 180, that is the minus terminal. Here I am also going to put the minus in this sine wave generation. For that purpose, I am also going to put as a minus for here. So this minus, that is the 180, again that is the 80. So 270, total 360 minus 270 is a 90-degree phase shift is occurred. The current phase shift is occurred, right? Now we are going to run the circuit. Okay, now I am going to run the circuit. Please see that the waveforms in the circuit. Yes, it may run. Okay, so please see the machine which may going to run at 2.5. Yes, so up to 0.5 the irradiation is increases. If the irradiation is increases, again the power given by the PV panel will also increases. But we are maintain that the constant power and variations in that in the load side, right? So here it can be changes, further changes. So again that is the 1 and 1.5. I am also going to take as that degree variations. So at the same time, if the variation is occur in that the 1, we are not exactly maintain the control, because during that time, that is the MPPT will take some time to find out on its optimum positions. Okay, so this is the point, the MPPT which may be going to find yes, the MPPT which may be going to find on its optimum position for this period, right? So it may be find out, again it may be going to constant. So during that time, that is the output power is changed. Please see, that is the output, that is the load output is that is the 8000 plus, it may be 8200 or 300 is obtained. Here we are going to see what is that it is the 7500 what we are going to obtain. Here that is the 1500, it may be what is the value, around 1200. Here please see 1200 value, this is the 1200. So what is the 7500 plus 8500, 8500, and upon from this it may be going to upload, that is the maximum power. So what is that the power here which is available? So that is, it may be reduced by the grid. Here that is the 7002 or 300. Here 6100 plus. So 6100 plus 1200, around 7000 something plus 8000. It may be going to here. So this is the entire variations. So here you may going to see, that is 850. What is the power? So 1457. 400. Please see 1457. So what is this? Some nearly 100 watts, nearly by 100 watts. It may be difference is occur. It may be considered as a losses of the entire system. So the losses may be in further reduced with a suitable control technology. Okay. So this video which may be present single phase DVR with PV and DC to DC converter, right? Again, the next video, PV wind and DVR with DQ control frame, we are going to see on later. Okay.